right. Okay. All right. So I did post, that's what I wanted to show you. I did post, now this is the instructor view. So there's a hidden assignment, which I can't get to. I have all these amazing assignments. You're gonna love them. No, I don't know if you will, but I can't get to them with the network outage. So that's why I posted this assignment here, just for something to do. And hopefully we'll have a solution sorted out. But I also posted just a quick formula sheet. Now, I'm gonna add to this formula sheet as we go. Okay, so right now it looks so itty bitty. So small, so cute. Don't worry, we're gonna add to this as we go. And it is hidden right now because I don't want you to see it. But as we go, just as a heads up, hey, this is what we just saw, although I'll add that one, right? We just saw that. And then this was an old version, but then we're gonna add to it and it's gonna be this beautiful formula sheet. Okay. That one's kind of outdated, so I'll post an updated one and I'll make it available, but don't let it scare you, okay? We're gonna kind of introduce things incrementally. Okay. I'm gonna put this into Notability, create new note, and stat 230, there. Okay. Let's see here. 2.1 is a huge section, right? So we're gonna continue 2.1. We'll see if we're able to wrap it up or not. And then if we are, we'll start 2.2 tomorrow, but I suspect we're gonna spend all week in 2.1, and that's totally fine. There's a lot to cover in there. Okay. Our quiz is next week on Friday. It's on chapters 1 and 2, okay? Quiz 1 is meant to kind of boost your morale, your spirits, right? It's supposed to be and just kind of a quick win for us to all start on a good note. And then, well, we'll talk about quiz 2 later. All right. I also posted these numerical summaries. I posted the PDF as well as the RMD file, which a Moodle can't handle RMDs, so it just prints it and then you have to copy it and paste it into a fresh RMD file. If you're in data science and you know what that means, then you can do that, but it's not something I expect. But this is just showing you how you would do these things in R. So today I'm going to be referring to this a little bit, but it's just as a reference, nothing crazy. Okay. All right. What I'm going to do is I'm going to grab this from last day. And we're going to pick up here. Kind of a fake review. Okay. But this is where I want to start, right? So it's just a continuation of your notes. Okay. So what we said was, okay, if I'm describing a distribution, right, which is going to be one of the main things that we're going to be doing, then I have to talk about the shape, I have to talk about the center and the spread. And we just kind of eyeball it. We're just getting a rough idea of numbers. Okay, what are some reasonable numbers? Okay. And then we said, okay, depending on the shape, right, that will determine the appropriate measure of center and spread, right? So now we're going to talk about numerical measures of center and spread. right? And so if I have a normal distribution, then I'm going to use the mean as my center and the standard deviation as my spread. Okay? If I have a non-normal distribution, so anything but a normal, right? I just lump it into non-normal. Then I'm going to use the median as my measure of center and the interquartile range as my measure of spread. Okay. This is what we will be doing in this course. And then, there are more sophisticated things like using the variance instead of the standard deviation. I'm sure there's some fancy measure for instead of the interquartile range, but this is what we're going to be doing. Okay? Now, the reason we have these different measure, yes.
You never use that.
I just write median. Yeah. Just because otherwise it's too many tildes and bars and hats and it's just too much. So I just write median. That's fine. But I'm just making a note because if you're reading a textbook or something like that, you might see it. So then it's good to know. Okay, so that's kind of we'll call it the end of the review. But what I was saying is that the problem with, or the reason we have these different measures of center and spread is because the mean and the standard deviation are going to be pulled, but mostly we talk about the center. The mean is pulled in the direction of extreme values. So if you have outliers, right, which I'm assuming is a term that we've kind of heard in the past, outliers are extreme values, right? So if you have outliers, then the mean is pulled towards those outliers, right? And so that's kind of a problem. Okay. So the problem with the mean there, and I guess, and standard deviation, although it kind of behaves in a different way. I did it. One of my students, or one of my teachers way back when, she would always, say something and then, oh, except to this scenario, and here I am, and it would drive me nuts. Like, how about you just tell me the general idea of things, and then here I am, well, the standard deviation behaves differently, and so bad. I don't want to do that. But let's talk about the mean. So the problem with the mean is that it will be pulled in the direction of outliers. Towards out. And I'll just clarify here, because if you haven't seen outliers, outliers are extreme values. You guys read the book Outlier? Malcolm Gladwell. It's really good. I always recommend it. It's kind of a fun take statistics. So he uses statistics a lot in all of his books, but Outlier compares successful people that are, so one person and one person was not successful. So it kind of compares. Anyways, it's a really interesting and fun read, but I know you guys don't have time for fun books yet. Only boring books. Yeah. And so what happens is, okay, so if you have a normal distribution, right, then the center is here, right? Sorry, that was a weird normal distribution to draw. I'll try better, right? Because it's symmetric, the center is in the center, right? It's not being pulled toward any direction, right? And so here, the mean is the center. Whereas if you have a skewed distribution about last day, I'll make it even. What's going to happen? So versus skewed distribution, if the mean is pulled in the direction of the outliers, right? So the values is that the mean is going to be pulled towards this tail, right? And so no longer a good measure of center, would end up somewhere down here, right? Because it's being pulled in the direction of the tail. You can think about it, and we'll look at an example, right? If I give you, if you find the average, which is the mean of 4, 5, 6, 7, right? And so just think about, okay, a reasonable average, 5.5 or whatever. I don't do math. The 7 to 70. Now the average is huge, right? Just because you've got that 170. So that's how the mean works. And so the terminology that we use here is that not robust to outliers. Robust means just strong and steady, right? And so when we say it's not robust to outliers, it means it's being pulled in the direction of these extreme values. And so we say the mean and we abbreviate S. Mean and standard deviation are not robust to others. Whereas we haven't talked about the median, we will, right? And we haven't talked about the interquartile range, but we will today. So whereas these measures are not going to change drastically if you have these extreme values. Question. Oh, I moved too fast. So then here, these guys, the median, oops, I write the mean again. The median and the interquartile range are robust to outliers. Okay. So last day we talked about how to calculate the mean. We all know how to do that, right? But then we translated that into sigma notation, right? The sum of all the x's divided by n, right? And so we're gonna look at the formula for the standard deviation and we're gonna pick it apart, okay? And the reason I do this, like I mentioned last day, is not because it's super important that you know how to calculate the standard deviation by hand. It's not, right? However you are able to find the standard deviation is fine by me, right? But we do need to have the skills and just the comfort of being able to look at a formula like the standard deviation and be able to say, oh yeah, I could do that if I had to, right? And so just to be comfortable with it. Okay. So the standard deviation which here's where it gets a little bit weird. When I talk about the standard deviation just as the words, I abbreviate it SD, okay? But when we use it in notation, right, mathematical notation, then I use a lowercase s, right? So it's just a matter of kind of different notations for different things. But it is on that formula sheet. I'm gonna grab that. Right, and so here, right, and this is the standard deviation is S. Okay? There are there are many different formulas that we could use, right? We could derive from these formulas, but these are the two main ones. Okay, they will find the same thing if you're doing it right? So it's just a matter of what information do you have? How do you prefer to go about it? I'm going to focus on this one, okay? Mostly because I think it illustrates what the standard deviation is better, okay? But this one here, let's just talk about this one. Okay? If you have your data set, right? You have one column of numerical data in your spreadsheet, okay? That's your X. Okay? So in order to work with this formula, right, you need the average of the x's, right? And you need the sum of the x's squared, and that's it, right? Everything else is just math, okay? And so here, then all you would need to do is you would need to make a new column with each of the x's squared, and then find that sum, and then that sum would be put into this placeholder. To me, that doesn't tell me anything about what the standard deviation is doing, right? So this one, I'm just going to make a note here. Although this formula is easier to work with, I will focus on the first one. First one. Okay. Right. Because all you would need here is you would need to find X bar and then square each value and sum. Right. Everything else is just ends, right? And as long as you follow proper order of operations, so BEDMAS, if that sounds familiar, right, then you're fine, right? You find the average of the x's, you square it, you multiply by n, and then subtract that from the sum, and then divide that all by n minus 1. N is your sample size, right? And then finally take the square root. If you don't take the square root, you'll variance, which is a measure of spread, not what we're going to be looking for, right? And I find that one's easier, but if you have 20 data points, you'd have to square each one, right? Add them all up. That's very tedious still, right? And so, I mean, just use R, I'll show you how, or Excel or something like that, and it'll just be able to find the standard deviation for you. There are online standard deviation calculators. So we're going to focus on this little guy, okay, and write it out kind of nice and big here. I've got the sum bars squared divided by n minus 1. Kind of similar, but there's a little bit of activity here. Yeah.
Why did we don't take the square and take because the purpose of taking the square is we don't get the negative value.
Yes.
What if we take absolute value and then we get the
Well, we take the root because we squared. And then, but if we take the absolute value, I feel like that's called the mean absolute deviation. It exists. It's just not commonplace. It's not one of those ones that we use all the time. Don't worry, everything exists. It's just for us, we use the square. And one of the things about the square, so what's this thing doing? So from each data point, and I've simplified the notation here, right? Because technically what's on here is you've got xi from I equals 1 to n, right? But I don't like it bogging it down, right? But what do I need? I'm gonna take away the mean, right? So I find the mean of all my x's, I still need that, okay? And then from each data point, I see how far is it from the mean, right? How far is x1 from the mean, right? And if it's below the mean, that value is gonna be negative, right? And so that's the first reason why we square, right? Is to make it positive, right? You square a negative number, it becomes positive, right? So all of a sudden we're working with positives, but also why am I going like this? The square is a parabola, right? And so it has this added effect of amplifying large distances, right? So if this value, so x1 is 1 unit away from the mean, right? In either direction, it doesn't matter. Then 1 squared is just 1, right? But then if I have 2 is now 2 units away from the mean, right? If I square that, all of a sudden that becomes 4 in my sum, right? And so it makes the spread larger, right? So it has this kind of added effect of not just making things positive, but also amplifying large distances from the mean, right? And so it's kind of multi-purpose, and that's why we use it, okay? But just to break this thing apart, the first thing you would do, and I'm gonna try to use my colors here. First thing you would do, number one thing, is calculate the mean of all your x's. Calculate the mean of x, right? That's the number one thing that you would do. Okay? The next step that you would do as you're picking apart this formula is you would take each of the values in your data set and subtract the mean, right? You're gonna have some positives, some negatives, right? And it's fine. Okay, so then the next thing you're gonna do is deal with this. Okay, so the second thing is subtract the mean from step 1 from each of the values of x. From step 1, from each value of x. X1, x2, x3, x4. All the way up to xn. Okay. What does this do? This tells you the distances, right? Exactly. So here, this gives us the distances of each point from the mean. Right? The standard deviation is a measure of spread, right? And so now we're starting to see that, okay, so it's based off of these distances from the mean, but then we do some manipulations on top of that. And so then the next thing we're gonna do here is we take each of those values and we square them. Oops. Square each value from step 2. Okay. Right. And this has what effect? Positive. So makes distances positive. Oops. Oh, yeah. And amplifies large distances. Less. No worries. So, okay, now we're ready for that sum. Right, so now this value here, notice how you just start in the middle and then you work your way out like an onion, right? But you have to start, you have to find the middle and then work your way out. And so step 4, I guess, is add up or sum all the values from 3. So this is kind of the cumulative squared distances from the mean. I'm not going to write that down because it's not, super important. It's this part that's important, right? The standard deviation at its core is just how far are things from the mean. So why does it only make sense if you have a normal distribution? Because if you're looking at how far things are from the mean, and the mean is not the measure of center, that doesn't make sense, right? You can still calculate it, right? It still exists, but it's not a good measure of spread. Okay. And then we've got, I'm running out of colors, I think, purple. Yeah, I know. There are these different tones, and I do go over here sometimes, but I like these strong, like kind of main colors. It's more playful. I'll go to purple, even though it's very similar to the pink. So 5, right? I'm not just finding n-1, but I'm also taking that sum and I'm dividing by n-1, right? And so divide the sum from step 4 by n-1, which is the sample size minus 1. The -1 throws people off, and that's fair. Okay, there's tons of literature as to why you would want to use n-1, but for our purposes, the reason we use n-1 is that it actually gives us a better estimate of the population standard deviation than if you just did n. And so there's lots of theory behind that, and that's all we're going to say about it. But it's just it's this weird kind of tweak that we have to make to get a better estimate of the population standard deviation. That's it. Okay, and then last but not least at all, arguably the most important part, is that you take the square root of that value, right? so many times, most of the questions that I get, especially from kind of later sections is, oh, I found this value, but it doesn't make sense. It doesn't work. And you forgot to take the square root. Right? I don't tend to make you do these calculations a lot, but when I do, everyone forgets the square root. So take the square root of the value from step 5. And then you're done. Yes.
I understand what we check the accuracy of how far the data is going.
Yep.
How far of data is going. But what about the standard deviation? Have you heard you still about accuracy standard? I know it means the spread of the data, but what it means by the spread of the data? Because our standard deviation mostly comes in the value 0.12 or 2.3 of
So the standard deviation, we use it to try to identify extreme values, right? So if I tell you, oh, I found a mosquito and it was 4 centimeters, what's your brain go? 4 centimeters? That's crazy. You found a mosquito that was 4 centimeters, right? What's your brain done? A typical mosquito is about 1 centimeter, right? Some small, some bigger ones, right? So your brain is thinking about the standard deviation. What's a reasonable amount of spread here, right? And then when I tell you, oh, I found a mosquito that was 4 centimeters, I don't know, right? Your brain goes, that doesn't make sense, right? We have some internal threshold of how many kind of, or how much spread I can allow until you say, oh, that's very unreasonable, right? I hope that there are no 4 centimeter mosquitoes out there. Maybe there are, right? But 10 centimeter mosquito, right? Your brain goes, no. I've seen mosquitoes, right? They're all typically around 1 centimeter, right? Some small, some littles, right? Some small, some little, some bigs, right? But in general, we have this idea of a mosquito. A mosquito is typically this big, right? And then, so that would be the mean, right? And then I'm talking about, okay, well, I could, I'm expecting maybe some small ones, maybe some a little bit bigger, but we have this internal measure of the spread, right? And so if I tell you that, oh, I saw a dog and it was this tall, right? You would say, that seems normal. Why? Because you know that the spread of the heights of dogs, it can be large, right? There's some very small dogs, there are some big dogs, right? And so then your kind of internal knowledge, right, which we don't always have, but that's what the standard deviation does for us when we don't have it, right? But your internal knowledge says, seems reasonable, right? And so that's why we use the standard deviation, is to identify these extreme values, right? Hopefully that mosquitoes, dogs, can talk about. Can talk about a lot of things, right? But a lot of things we know what would be extreme, right? And but a lot of the data that we deal with, that's not necessarily the case, right? So then we rely on the standard deviation to tell us, we're like, hey, is this normal or what, right? And so that's what it's doing. So I'll make a quick note here. We will come back to it in a later section or a later chapter. So we will, I promise. But for now, it's just the measure of spread. Okay? And so we use measures of spread to help us identify extreme values. Okay. Measures of spread, of course, is the standard deviation. It can be the variance, which we haven't talked about, but it can be the variance and it can be the interquartile range, right? So in general, we use the spread to identify extreme values. Maybe sort of. We'll get there. Yeah. Yeah.
Do a question like we can get a better.
Oh, you want to find the standard deviation? Okay. Can do. Let's see here. Now, oh, I did not grab it. That's okay. I have an example. Where's the chapter one? You guys weren't supposed to see that yet. I'll bring it in later. Okay, let's see here. Where is it? We don't do a lot of this anymore, but the example I want is here. Yeah. So the example that I'll be referring to is the GDP. So the success of companies expanding to developing regions of the world depends in part on the prosperity of the countries in those regions. Here are the World Bank data on the growth in domestic product, which we call the GDP, which are in percent per year. For the period 2000 to 2004 in countries in Asia, not including Japan. Okay. And so we've got the country, looks like alphabetically, and its corresponding GDP, right? So in this case, right, what's my X? My X here is the GDP, right? And then I can have X1, X2, all the way up to, how many do I have? What's my sample size? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So X12. So N equals 12. Okay. Okay. So what we would do, right, is if we had to calculate the standard deviation here, what would I have to do? I would need to find the mean. Okay. Now, this might be a fun time to introduce that numerical example, I think. Summary. Because for us, I'll show you how, but we're not going to do the calculation by hand because that's crazy. The problem is that when I find the mean, which remember is the first step of finding the standard deviation, right? What's the first thing we have to find the mean, okay? And the mean, just skipping ahead, because I don't want to do this calculation on my calculator, that's boring, right? The mean is 5.108333333 repeating, presumably, okay? And so one of the problems that we face when we're doing it by hand is, unless you're storing that value, I would need to round it, right? But rounding it gives me kind of an inaccurate approximation. And so let's go back. Okay. So what I would do is I would take all my x's, copy them. Okay. So the method for finding s that I would use is I have my x's here. Wait. And then I'm gonna find, oops, sorry. That's the other formula, the easier formula, right? The first one I introduced, which in terms of calculation is easier to work with, right? Because you just need to square each x and add them up, right? And then do a little bit more math, but nothing crazy, right? And so, but for us, let's talk about this mumbo jumbo here. So what I'm gonna do is I'm gonna take xi minus x bar and make a new column, right? So 5 squared, or 5.2 minus 5.108, 3 repeating. I'll just show 1, right? Then I make another column of xi minus x bar squared, which I'm not gonna do it because there's no reason to. 1.083 repeating squared. Of that number from before, right? But you would square it. You'd have a list of all these numbers. You would add them all up, and the result would be the sum of the xi minus x bars squared. So then you'd have that placeholder, divide that by n minus 1, and then take the square root, and then you have the standard deviation. But like I said, for us, it's important that you're able to find the standard deviation somehow. So how I'm going to show you is just using R, which would not involve rounding or anything like that, right? Because it just does it. Excel, easily, you can find the standard deviation as well. Okay, let's see here. Yeah. Is that sort of satisfactory?
Okay, from the example, we got the average being 5.1.
Yeah.
So what that basically means, the average GDP of Asian country is 5.1.
Yeah.
And the standard deviation was coming up to 2.1.
Yeah. So now, for us as humans, it doesn't mean a ton yet. It just is going to be a way to identify, what's a reasonable number and what's an unreasonable number for GDP, right? And so here, so what you can do in R, if you wanted to try these things in R, and that's why I posted these numerical summaries, you can make an object called GDP, and then you use this arrow. You can use an equal sign. If you're old school like me, started with equal signs, and then all of a sudden, the R community was like, you shouldn't use equal signs, you should use the arrow, because there's one obscure situation where it would mess things up. Yeah. You can use Excel, right? You can use an online calculator, anything. Yeah. The answer will be the same though, so it doesn't matter. As long as you specify that you want the sample standard deviation, because it's a sample. But I'm not going to make you calculate the standard deviation on a quiz. It's something I would make you do in an assignment for practice. but not a it's not a quiz thing. Okay? It's not important. I just expect you to be able to find a way to calculate it. Yeah? So here's the way that I'm going to show you sort of is so to enter a data set by hand into R, use the lowercase c for concatenate. Concatenate means put things together, and bracket, and then you enter your data with commas and then end bracket. Now I can talk about GDP, and it's a list of these numbers. Then we can do things like I can find the mean of GDP using the mean function. And I guess I should have given the output too. You know what? I will. I'm gonna delete this one. Put in the bigger one. Okay. So R has these built-in functions, same with Excel. Just need to find what the function name is, and of course it's gonna do it for you. Okay, and so here, when I take the mean of GDP, if I want to use it again, I would store it as a name that I could call. I don't have to type mean of GDP again, right? I can write av GDP or whatever you want to name it. Okay, and so we can find the mean of GDP, right, like this, or store it in some object. And then the SD command just finds the standard deviation of the GDP. And it goes through, it uses unrounded values of the mean, whereas if we're doing it by hand, you would likely round this to some number of decimals, right? 3 decimal places, 5.108. But then you're lobbing off 3 repeating, right? And so your value is going to be just slightly off. And so however you want to find the standard deviation, in this case, it's 1.819819. You can ask it to give you more decimal places if you wanted to. I wonder if I kept the okay. And then I show you just a couple of things that you can do with the mean. That's more for your own time. It's not for our purposes here, right? But somehow be able to find the standard deviation. What's another way? Well, Excel, but I don't have Excel on my iPad, right? But you can search for a standard deviation calculator. I'll pick the first one here, and you enter all the data. And here's where it's important that you change it to sample. Okay? So I don't want to enter all the values, but I will save this and bring it in here, or find an online calculator. Kind of crop the things that we maybe don't need right now. All right, and just be sure to set it to sample. We only calculate sample standard deviations in this class. So then you would enter your data, find it, use it, move on. Okay. Any other questions before I move on to the median? Okay, so, right, thinking about our table that we started with, right? We've talked about the mean and the standard deviation, and just to ingrain it in your brains, it's only for a normal distribution. You will always be able to calculate it, right? But it's only applicable if you have a normal distribution. So that's something to keep in mind. Computers will just calculate anything you want, right? There's no internal stop for what's appropriate. That's for us to decide, right? Is this an appropriate measure? Okay. And even looking at, if I go back to here, right, I've got this histogram. Now, before you tell me that it's skewed, I highlight that we have a very small sample size, right? And so we have a size of 12. And for that reason, I want you to be really hesitant to talk about this one data point. It's only one, right? And so the argument is going to be, okay, well, if I collected more data, I would expect it to even out, right? And so I would expect it to approach a normal distribution. Okay? That's why it's really kind of, you're just doing a blanket over top. And if you can kind of convince yourself that, sure, I might have another one here, right? A couple more building up, right? It would approach a normal distribution. And the reason we use that argument is that it would approach a normal distribution is because all our analyses later, one of the assumptions is we have a normal distribution, right? We can't do it unless we say we have a normal distribution, right? And so here, looks like I even have it. Copy. Or maybe I can put it somewhere. Where can I squeeze it in? Too many images. Okay, so here, I would argue that it looks approximately normal. And so here, but it's possible, and I'll just have it in your notes and zoom it in, right? It's possible that as we collect more data, the distribution would approach a normal distribution, right? And so then, therefore, oh, I guess that's too small. Therefore, the mean and standard deviation are appropriate measures of center and spread. Okay. Now we can talk about the median. The median is, the simplest way is, it's the data point that splits your data in half, right? You've got 50% of your data below it, you've got 50% of your data above it. That's it, that's the median, okay? And so what's the first thing that you'd have to do? You'd have to sort your data to find that midpoint, right? And so that's your first step when you're finding the median and the interquartile range, is you have to sort your data. Okay? So the median is the value that splits your data in half. Okay? Which means you have 50% below it, 50% above it. To find the median, we first need to sort our data. we first need to sort our data. Okay. Smallest to largest feels obvious, but I'll write it. If you're feeling strange, you could go largest to smallest, but that, I don't know why you would do that. Seems weird. Feels weird. Okay. So again, I want to use that GDP data just as a data set that we can manipulate. And so I'm going to grab this. Oops. Wonder if I can erase. I cannot. Okay, that's fine. That's fine. So what I want to do is I want to sort this data. And as I go, right, especially because this is something that I'm going to quiz you on, right? And so it's good that to know how I expect to see things, okay? And so it's going to be very important that number one, you have used all your data points, right? That's a sure way to get the wrong answer, right? If you don't use all your data points. So for me, I like to just go through and cross out the values as I list them, okay? And so step number one, sort the data. And I'll just make a note that n is 12 here, just as a reminder, because then I'll go back and make sure I have 12. I see 2.9, and I'm also looking at my notes here. I don't want to, that's okay, you have it earlier. 2.9, and then I have 3.2, 3.9, 4.1, 4.4, 4.6, 4.7, 5.2, where is it? There. 5.4, 6.2, 7.3, and 9.4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Phew. Okay. And it might be worthwhile just making sure you have the right numbers, right? But because everything's going to hinge on this list now, right? So from here, we've sorted the data. I wrote it all sloppy, and that's fine. It's going to be a lot easier if you're able to keep it all in one line, because what are we going to do? The median is the value that cuts it in half, right? So the first thing we're going to do is we're going to find the median, right? And so, oops, step 2, find the midpoint, which is the median. I use my very fancy patent pending boop, boop, boop method, where you take 2 fingers and then you boop, 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 boop your way into the middle, right? And so that's, I think it's the easiest way to do it. It's obviously not fancy or anything. There are formulas, but the formulas actually only tell you where the median is. It doesn't tell you what the median is, right? So that's why I find just counting in is the easiest way to do it, right? And so here I have long arms, but not like that, right? So then I would go boop, 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 boop. I land on 2 values, okay? And the sound effects are important. Boop, 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 boop. All right. And so here, because I can, I'm going to copy these values. Okay. And then we count in from both sides. Boop, 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 boop. Ta-da. Yes, 4.65. But why? Because we would take the average of the two, right? So how we denote that is to show the reader, me, that you're taking the average of these two, which is exactly what you're going to do, right? We circle these two to show that you landed on both of them. Okay? And then what we do is we draw a line down the middle, and that line is the median, right? Not the 4.6, not the 4.7. And the median is the average of those two. Very confusing, right? We take the mean to find the median. Right, but here, this is the median, and it is 4.6 plus 4.7 divided by 2, which is 4.65. Okay. And so here, you're going to count in from both sides, or boop in from both sides. To find the central value. Okay. As kind of an alternative, right? What if I removed this 9.4 value, right? And we just have a new data set where without the 9.4, right? Just to show you the other way that the median could present itself, because it could actually be a number, right? And so here, let's see, versus if we remove the 9.4 data point, so here I'm just going to remove that. Okay, and then I'm going to do the same thing. I always have to be careful that I don't go cross-eyed. Boop, 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 pew. When I land on a number, that is the median. Yeah, if it helps for consistency, the average of one number is just itself. So sure, but yeah. The problem though is this is how I expect to see it on a quiz, right? But if you're doing it in R, if you're checking your work in R, it will do a more sophisticated weighting, right, than just the average. Okay. And so that's just a heads up, right? If you're checking your work, which I encourage you to do, right? If you've calculated the median or the mean or the standard deviation or something, I encourage you to check your work using some sort of software, right? That's good. And you'll know, right? But also sometimes it gets a little tricky. And so, and I think well, I'm pretty sure I have, okay, I'll introduce it because I have it in terms of the quartiles, which we're not quite there yet, but I will bring it in and just show you how it's slightly different, right? When R calculates the median, it doesn't just take the average, it looks at all the other data points and says, oh, I should be a little bit more over to this side or a little bit more over to this side. It just is a little bit fancier than what we do by hand, but very similar. Yeah. Okay. That's how you find the median. I think we're ready to find the quartiles. Now, remember, the measure of spread for non-normal data is the interquartile range, right? Which inter means between, quartiles is just kind of, if you think about it, are the data points that split your data into quarters, right, instead of in half. And then the range, of course, is the distance between those two quartiles. Okay? So that's what we're building up to here. So the quartiles split your data into quarters. Right, and so we use the notation Q subscript 1 as the first quartile. Quarters, right? We have 25% of the data below it and 75% of the data above it. Right, 25% below, 75% above. Q2, we've already seen actually, the second quartile is the median, right? Because then you have 2 quarters below and 2 quarters above, which is really just half and half, right? So usually we don't talk about Q2, but it is the median. Okay, so the second quartile is the median, right? 50%. Are you guys okay if I just write below, above? Right, 50%, 50%. I'll write it properly for the second one, which is Q3, or the third one, I guess, which is the third quartile. The third quartile has 75% below and 25% above. So to find the quartiles by hand, now we're just basically finding the median between the median and the minimum, boop, 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 right? And then Q3, again, from the median to the maximum, use the boop, boop, boop method again, boop, 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 find Q3. Okay, so what does this look like? I'll write it out. To find the quartiles by hand, we use the boop, boop, boop method. Again, in the lower and the upper halves of the data. Oh. There are rules. So I didn't used to like to play games, board games and stuff, but my husband's family, they play a ton of board games. And so now I'm a gamer because I play a lot of board games. And so, and part of the fun for me is just learning the rules and kind of mastering the rules. I know that's a weird, fun thing to have. But for me, just kind of knowing the rules and just following the rules, I don't know, it's kind of a fun game. And so same thing here. There are lots of rules that we have to follow, but once you've mastered them, they'll come naturally, right? And so one of the rules is depending on how you found the median, right? If you use the average, then neither of these values are the median, right? So in terms of finding your quartiles, in this case, I need to pull it down because I'm not that tall, right? The median is here. So then I am allowed to use 4.6 and 2.9, right? Boof, boop. And then the average would be my first quartile. Okay. As opposed to, if I've used 4.6 as the median, I'm not allowed to use it when I'm finding the quartiles. Okay. And so then I would start here at 4.4, right? And 2.9. Boop, boop. And then I'd end up at 3.9. So it depends on how you found the median. That's going to tell you how to find the quartiles. Yeah.
Why
Oh.
should we not take 4.6?
Because I've used it as the median. So it's not a player anymore.
But we did use that before, like 4.6 as a median.
Here?
Yeah.
Yes, but it is not the median itself. The median is here at this line.
If we use like even values, like we have 12 values, so we
Yeah.
took 2 values as a median. But if we took as the 4 value, like 11, and
Yeah.
if you go to the- so we have 1 median.
So it will depend on your sample size, how it's going to play out, right? And I usually, make you practice with a sample size of 9, 10, 11, 12, just so you can see kind of the range, right? But I'll never make you use a huge data set. It's always going to be kind of a little itty bitty fake data set that you're using. And this isn't life or death stuff. It's just when you're doing it by hand, you have to follow these rules. That's just how it is. Okay? And so depending on how we find the quartiles, depends on how we found the median. Okay, so I'm gonna grab these. Wait. Okay, so here, the median is at the line versus the median is one of the values. Right, those are the two scenarios that we have. So the first quartile here, I'm allowed to use 4.6 because the median is here at the line. Okay. And so here, 1, boop, 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 boop. So again, same notation, Q1 is 3.9 plus 4.1 divided by 2, which I'm pretty sure is 4. Same thing with Q3. Right now, we're just doing it with the upper half, but again, the median is at the line. And so I'm allowed to use boop, 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 boop. Q3 is 5.4 plus 6.2. And you know what? how about that? Divided by 2, which is 5.8. Versus now the median is one of the values, so it just changes slightly, boop, 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 boop. Q1 is 3.9. Is 3.9 that different from 4? No, right? But we just need to be able to learn rules and apply them, right? Is that a question? Just an agreement? We need to be able to learn rules. So then, boop, boop, boop. When I say boop, you say boop, boop, boop. 5.4, right? Is 5.4 that different from 5.8? No, right? Ultimately, doesn't make a difference. Just real quick, because I have the 2 minutes, still mine. That leads us to the interquartile range, the distance between the quartiles. Okay, so the interquartile range which is the IQR. The IQR is Q3 minus Q1. Why do I do it in that order? Just because I need it to be a distance, which is positive, right? And Q3 is always larger than Q1 unless you did something wrong, right? And so, so then the interquartile range is the distance between Q3 and Q1. So in this case, up here, right, let's say the IQR for this guy is 5.8 minus 4.0, which is 1.8. And for this guy, the interquartile range is 5.4 minus 3.9. And that's too much math for me. I don't have it. There's no way of knowing. That's okay. I can do it. I can do it. No, you guys can do it. What is it? 4.3? What? 1.5. Thank you. You just have to say it with confidence. 2. No, it's not. There. Okay, that's good for today. We'll talk more about it tomorrow, obviously. But that is good for today. All right. If you have any questions, let me know. Otherwise, I'm going to stop this recording.